The morning of June 6, 1944, brought chaos to the skies above France. Through scattered clouds, a damaged American fighter plane dropped toward the earth. Smoke streamed from its engine in a thin gray line. The aircraft bore distinctive markings. Squadron code QPG adorned its fuselage. Someone had painted the nickname Jerry on its nose. Lieutenant Thomas Fraser gripped the controls of his wounded P-51 Mustang. The 334th Fighter Squadron pilot had become separated from his formation during the massive aerial battles supporting the Normandy invasion. His aircraft, serial number 43-24825, was a P-51B-15NA model. The Packard Merlin engine coughed and sputtered. Oil pressure dropped steadily. Fuel gauges showed worrying numbers. The French countryside rushed up to meet him. Fraser fought the controls as his fighter struck the ground hard. Metal screamed against stone and earth. The aircraft skidded across a farmer's field. It finally came to rest near a hedgerow. Steam rose from the crumpled engine cowling. Fraser survived the violent landing. He would spend the war's remaining months behind barbed wire. But his abandoned Mustang was about to begin an extraordinary journey. German salvage teams would soon arrive at the crash site. They had perfected their methods during years of recovering Allied wrecks across occupied Europe. The damaged fighter lay relatively intact in that Norman field. Within days, German recovery specialists appeared. They examined the wreckage with practiced eyes. Structural damage was assessed. Critical components were checked for viability. The verdict came quickly. This particular machine could be saved. Transport trucks arrived to collect the prize. The Mustang began its journey eastward across occupied territory. Its destination was Rechlin Testing Center. This facility sat approximately 100 kilometers northwest of Berlin in the Mecklenburg region. Here, the Luftwaffe conducted its most important aircraft evaluations. Rechlin's workshops buzzed with constant activity. Skilled technicians worked on various projects. Captured Allied aircraft filled several hangars. Each machine told a story of aerial combat. Battle damage scarred their surfaces. Bullet holes punctured wings and fuselages. Some showed fire damage. Others bore the marks of rough landings. Fraser's Mustang joined this collection of prizes. German engineers studied every detail of its construction. They marveled at American manufacturing techniques. The quality surprised many observers. Official propaganda had painted a different picture of American aircraft production. Repairs began immediately. The work required considerable ingenuity. Original spare parts were impossible to obtain. Technical manuals existed only in English. Factory specifications remained locked away in distant American facilities. German technicians relied on their skills and improvisation. Components were salvaged from other crashed P-51s scattered across Europe. A nose section came from one wreck. Wing panels arrived from another. Engine parts were gathered from multiple sources. Slowly, one complete aircraft emerged from several damaged ones. The Packard V-1653 Merlin engine demanded careful attention. This power plant represented sophisticated American engineering. It featured a two-stage, two-speed supercharger system. Maximum output reached 1,490 horsepower at 13,250 feet altitude. Boost pressure climbed to 61 inches of mercury under full military power. German mechanics had never worked on such an engine before. They studied its construction with fascination. The intercooled supercharger system was particularly impressive. This technology delivered substantial power at high altitudes where German fighters struggled. Wings underwent thorough inspection. Control surfaces were checked for proper operation. Hydraulic systems received pressure tests. Every line was examined for potential leaks. Fuel tanks needed careful attention. Any crack could prove catastrophic during flight operations. The distinctive Razorback canopy required delicate repair work. Its framed construction limited rearward visibility compared to later bubble canopy models. But German technicians preserved its original configuration. They wanted to evaluate the aircraft exactly as American pilots flew it. Four 50-caliber Browning M2 machine guns had been mounted in the wings. German regulations strictly prohibited arming captured aircraft. Safety concerns demanded this precaution. The weapons were removed and replaced with ballast weights. Proper weight distribution had to be maintained. Paint schemes told their own stories. The original American markings disappeared under new German colors. Luftwaffe code T9 plus HK replaced squadron identifiers. Bright RLM-04 yellow covered the tail and undersides. This vivid color ensured German pilots wouldn't mistake it for an enemy aircraft. The propeller spinner received yellow paint treatment. A red band adorned the engine cowling and nose section. These markings followed standard Luftwaffe procedures for captured aircraft. Every detail had to conform to identification protocols. Weeks of meticulous work finally produced results. The restored Mustang sat on Recklin's flight line. Fresh German markings gleamed under hangar lights. The aircraft looked ready for service. But this machine wasn't destined for ordinary duty. Major Theodor Rosarius commanded one of the Luftwaffe's most unusual units. The Wanderzirkus Rosarius operated under official designation as 2. Staffel of Versuchsverband OKL. This specialized organization evaluated captured Allied aircraft through systematic testing and demonstration programs. Rosarius understood a fundamental problem facing German fighter pilots. Combat reports provided fragmentary intelligence about enemy aircraft capabilities. These accounts often conflicted with each other. Battle conditions created confusion and uncertainty. Pilots needed direct experience with Allied machines. The concept wasn't entirely new. Both sides had tested captured aircraft throughout the war. But Rosarius organized the approach systematically. His unit maximized the tactical value of every captured machine. They didn't simply conduct static evaluations at secure facilities. Instead, the Wanderzirkus traveled across Germany and occupied territories. Captured aircraft visited operational Luftwaffe bases. Frontline pilots could examine these machines up close. They watched aerial demonstrations. Selected pilots even flew mock combat missions against them. This program addressed critical training deficiencies. German pilots trained primarily against their own aircraft types. They learned tactics optimized for fighting similar opponents. Enemy fighters possessed markedly different performance characteristics. American pilots employed different tactical approaches. German fighter pilots faced a dangerous blind spot. Their training emphasized short-range interception missions. Fuel capacity limited flight duration to roughly 90 minutes total. American fighters demonstrated dramatically different capabilities. Their range and endurance far exceeded German expectations. Recovery operations for Allied aircraft had become highly systematized by 1944. Specialized salvage units operated across occupied territories. Bergbataillone, or salvage battalions, worked with remarkable efficiency. They secured crash sites quickly. Damage assessments followed established procedures. Repairable aircraft were transported to centralized facilities. Statistical probability made captures inevitable. Allied forces flew thousands of sorties monthly. Mechanical failures occurred regularly. Battle damage forced emergency landings. Navigation errors led aircraft over hostile territory. Weather conditions created additional hazards. Fuel exhaustion affected long-range missions. Not all crashes resulted in total destruction. Some pilots executed controlled landings that preserved their aircraft. Structural damage could often be repaired with available resources. Fraser's P-51B fell into this category of recoverable prizes. The aircraft had sustained damage during intense fighter sweeps over Normandy. Engine problems forced the emergency landing. German territory still extended far inland, despite the invasion. Recovery teams reached the site within hours of impact. Examination procedures followed standard protocols. Crash damage was carefully assessed. Airframe integrity received close scrutiny. The verdict proved encouraging. Despite battle damage and impact forces, the structure remained essentially sound. repairs could restore the aircraft to airworthy condition. Specialized transport vehicles arrived at the crash site. The Mustang was carefully loaded for its journey eastward. Rechland Testing Center awaited this latest addition to their collection of prizes. Rechland had served as the Luftwaffe's primary evaluation facility since February 1936. The complex included extensive workshops equipped with specialized tools. Multiple test ranges supported various evaluation protocols. Runways were specifically configured for experimental flight operations. Lake Muritz provided a scenic backdrop for this center of aeronautical activity. But the work conducted here was deadly serious. German survival in the air war depended on understanding enemy capabilities. Every captured aircraft represented a potential intelligence windfall. Technicians at Rechland possessed remarkable skills in reverse engineering. They worked without original documentation or factory support. Parts had to be fabricated from raw materials or salvaged from other wrecks. The challenge demanded creativity and technical expertise. Fraser's Mustang presented typical problems. Engine components needed replacement or repair. Control systems required adjustment. Hydraulic lines had to be pressure tested. Fuel systems needed thorough inspection. Electrical wiring demanded careful examination. The two-stage supercharged Merlin engine fascinated German engineers. This power plant delivered performance that single-stage German engines couldn't match at altitude. The intercooling system was particularly sophisticated. It maintained power output where German fighters struggled. Canopy repairs required delicate work. The framed structure had to be rebuilt precisely. Any distortion would affect pilot visibility. The Razorback design already limited rearward vision compared to later models. Perfect reconstruction was essential for accurate evaluation. Wing structure underwent comprehensive inspection. The laminar flow airfoil sections gave the P-51 its distinctive appearance. These advanced wing designs delivered exceptional aerodynamic efficiency. Drag remained low across a broad speed range. Lift characteristics stayed predictable from approach speeds to maximum velocity. Manufacturing quality impressed German observers. American production methods emphasized consistency and reliability. Parts fitted together with remarkable precision. Surface finishes exceeded German expectations. The overall construction philosophy prioritized durability over weight savings. Test flights would soon reveal the true capabilities of this captured prize. German pilots approached their first encounters with considerable skepticism. Official propaganda had shaped their expectations about American aircraft design philosophy. Prevailing attitudes held that American engineering emphasized quantity over quality. Mass production supposedly sacrificed sophisticated design for manufacturing simplicity. These comfortable assumptions were about to face a harsh reality check. The moment experienced German test pilots settled into the Mustang's cockpit, preconceptions began crumbling. Ergonomic design impressed pilots accustomed to cramped German fighters. Controls were logically arranged within easy reach. Instruments were clearly marked and sensibly grouped by function. Visibility exceeded what Messerschmitt Bf-109 pilots experienced daily. Even the Razorback canopy provided better sight lines than heavily framed German designs. Rearward vision remained limited but still superior to Bf-109 standards. Seat comfort surprised pilots used to Spartan fighting compartments. Multi-hour missions became less fatiguing in properly designed cockpits. Pilot effectiveness remained higher when physical discomfort didn't create additional stress. Engine start procedures proved straightforward. The Packard Merlin responded smoothly to throttle inputs. Power built progressively and predictably as the aircraft accelerated down Rechland's runway. The four-bladed Hamilton Standard propeller bit efficiently into the morning air. Takeoff performance exceeded expectations. The roll was noticeably shorter than anticipated for an aircraft of the P-51's size and weight. Substantial power output combined with efficient aerodynamic design to minimize ground run requirements. Once airborne, the Mustang revealed handling characteristics that challenged fundamental German assumptions about American aircraft design. Flight controls demonstrated beautiful harmonization across the entire speed envelope. Aileron, elevator, and rudder forces remained perfectly balanced from approach speeds to maximum velocity. Control response was crisp and predictable without displaying oversensitivity or nervous handling. The aircraft could be maneuvered aggressively without dangerous tendencies toward departure from controlled flight. Roll rate significantly exceeded Bf-109 capabilities and approached the exceptional performance of the Focke-Wulf 190. German test pilots systematically explored the Mustang's performance envelope through carefully planned evaluation flights. Standardized maneuvers revealed strengths, limitations, and any hidden dangerous characteristics that could prove fatal in combat situations. Climb performance generated considerable concern among German observers. The P-51B maintained excellent rates to altitudes exceeding 30,000 feet. The two-stage supercharged Merlin continued producing substantial power where German single-stage engines gasped for adequate airflow. High-altitude capability particularly worried German tactical planners. American bomber formations typically operated between 25,000 and 30,000 feet. Defensive firepower remained effective at these altitudes. German fighters equipped with single-stage superchargers struggled increasingly to intercept effectively. Speed trials conducted under controlled conditions confirmed clear Mustang superiority in this critical category. The P-51B achieved approximately 440 miles per hour at optimal altitude with military power settings. This significantly exceeded the Messerschmitt Bf-109G's approximately 386 miles per hour and the Focke-Wulf 190A's roughly 408 miles per hour. Substantial speed advantage proved tactically decisive. American pilots could dictate engagement terms according to their preferences. They could choose when to attack pursuing fleeing German fighters when conditions favored combat. Equally important, they could disengage from unfavorable encounters by accelerating away from German fighters lacking sufficient speed to pursue effectively. German pilots discovered they couldn't force combat on Mustang pilots who recognized unfavorable situations and chose to avoid engagement. This fundamentally undermined traditional German tactical flexibility that depended on forcing opponents into disadvantageous positions. Wing design based on NACA laminar flow airfoil sections gave the P-51 its distinctive appearance while delivering exceptional aerodynamic efficiency. True laminar flow remained elusive under operational conditions due to manufacturing tolerances, surface imperfections, rivets, paint application, and operational wear patterns. Nevertheless, the P-51's wing generated substantial lift with minimal drag compared to conventional airfoil designs. This significantly contributed to remarkable range and fuel efficiency that distinguished American fighters from their German counterparts. Dive performance revealed another area of clear Mustang superiority. The aircraft could dive at very high speeds without encountering severe control stiffening that plagued many fighters approaching maximum design speeds. Pilots could execute recovery from steep high-speed dives without excessive physical effort or fighting against locked controls. Airframe stability remained consistent throughout high-speed maneuvers without tendencies toward flutter, buffeting, or structural failure. German test pilots noted this capability with particular interest because diving attacks represented primary German tactical doctrine for engaging bomber formations and escort fighters. Turn performance presented a more complex picture, requiring careful analysis. The Mustang couldn't match the sustained turn rate of the Bf-109 in level flight at moderate speeds. The German fighter benefited from automatic leading-edge slats that deployed during high angle of attack maneuvering and delayed wing stall during tight turns. In sustained slow-speed turning fights at medium altitudes, the lighter and more compact Bf-109 held measurable advantages in turn radius and turn rate. However, Systematic testing revealed that the Mustang's superiority in speed and climb rate allowed skilled pilots to avoid sustained turning engagements entirely. Energy tactics proved far more effective than traditional dogfighting approaches. The Mustang excelled at converting speed to altitude and altitude back to speed efficiently. This capability allowed pilots to maintain energy state throughout combat maneuvering. Structural strength and robust construction impressed German engineers who examined the airframe systematically at both Rechlin and Göttingen facilities. The aircraft was substantially built with significant safety margins engineered into critical components throughout the structure. This robust philosophy contrasted markedly with German design approaches that push structural limits to absolute minimums, pursuing weight reduction and maximum performance. The P-51 could sustain significant battle damage that would have destroyed lighter German aircraft while still returning successfully to base. American engineering philosophy clearly emphasized survivability and maintainability over absolute performance optimization. Somewhat higher empty weight was accepted in exchange for durability that kept aircraft and pilots operational longer. Range capabilities astounded German pilots accustomed to severely limited endurance in their own fighters. German aircraft rarely exceeded 90 minutes total flight time, including combat operations. The Mustang demonstrated dramatically different capabilities that fundamentally changed tactical possibilities. The fuel capacity of the P-51B dwarfed anything German aircraft could carry. Internal tanks held massive quantities compared to the Bf-109 or FW-190. The wing design worked like magic. Aerodynamic efficiency turned fuel into incredible distance. German pilots couldn't believe what they were seeing. 8-hour missions seemed impossible to them. Their own fighters barely managed 200 miles on a good day. Drop tanks hanging beneath the wings changed everything completely. The Mustang could fly deeper into Germany than anyone thought possible. German pilots stared at the numbers in disbelief. Their combat radius looked pathetic next to American range. This wasn't just an advantage, it was overwhelming superiority that reshaped the entire war. Bomber escort missions had followed predictable patterns before the Mustang arrived. German fighters knew the game perfectly. Wait in the shadows. Watch Allied escorts reach their fuel limits, see them turn back toward England, then strike the helpless bombers. The most dangerous part of any mission happened deep in German territory, right where escorts couldn't follow. The Mustang destroyed this comfortable arrangement instantly and completely. No more waiting games, no more vulnerable bombers flying alone. American escorts stuck with their charges from takeoff to landing. Every mile of the journey included fighter protection. German pilots found themselves fighting through screens of escorts just to reach bomber formations. Strategic implications hit Luftwaffe commanders like hammer blows. The old tactics were finished. German fighters faced a terrible new reality. Fight your way through superior escorts or watch bombers destroy your homeland unopposed. Risk increased dramatically on every mission. Survival rates plummeted accordingly. German test pilots who flew captured Mustangs came back amazed. The controls felt perfectly balanced. No excessive strength needed. No delicate touch required either. The aircraft responded exactly as intended every time. Aggressive maneuvering felt natural and safe. Violent combat turns never threatened control. Average pilots could extract good performance from this machine. Exceptional pilots achieved remarkable results by pushing the envelope further. The Mustang forgave pilot errors while rewarding skill. German pilots recognized superior engineering when they felt it. This aircraft made flying easier and fighting more effective. Ground crews familiar with German maintenance headaches found the Mustang refreshingly accessible. Engine cowlings opened in logical sections. The Merlin power plant sat exposed for easy servicing. Fuel lines ran where mechanics could reach them. Hydraulic components made sense. Electrical systems followed clear patterns. Panels throughout the airframe removed quickly with basic tools. Internal systems welcomed inspection and adjustment. Repairs that took hours on German fighters finished in minutes on the Mustang. The entire design reflected American thinking about operational availability. Aircraft on the ground contributed nothing to victory. Rapid turnaround meant more sorties per day. Higher operational rates translated to combat effectiveness. German aircraft might achieve impressive performance in perfect conditions. The Mustang delivered consistent performance day after day. Reliability mattered more than theoretical capabilities when bullets started flying. The Wanderzirkus Rosarius loaded their captured Mustang onto transport trucks in late 1944. The repaired aircraft, designated T9 plus HK, would visit operational bases across Germany. Frontline fighter units needed to see what they faced in combat. Demonstrations worked better than written reports. Seeing enemy aircraft up close changed everything. Each stop followed the same careful pattern. Temporary operations established quickly. Comprehensive flight demonstrations showed German pilots exactly what Allied aircraft could accomplish. Specific tactics emerged from these sessions. Countermeasures developed through direct observation. Weaknesses revealed themselves under controlled conditions. Captured aircraft taxied past assembled German personnel, creating surreal scenes. Enemy fighters bearing German markings moved among home-built machines. Bright yellow identification paint marked them as demonstration aircraft. The psychological impact hit immediately. Abstract enemies became tangible threats rolling past on landing gear. Flight demonstrations followed taxi displays with experienced German test pilots at the controls. Carefully choreographed routines showed specific capabilities through dramatic visual proof. Aerobatic maneuvers impressed observers more than technical specifications ever could. Performance numbers came alive through actual demonstration flights. The Mustang demonstration began with high-speed passes at treetop level, engines screaming at full throttle. Speed advantage over German types became immediately obvious. No German fighter could match this velocity in level flight. The sound alone told the story of overwhelming power. Climbing demonstrations followed with test pilots pushing toward 30,000 feet. The two-stage supercharged engine pulled the aircraft upward with relentless power. High-altitude capability exceeded anything German fighters could achieve. Thin air that choked German engines fed power to the Merlin. Roll demonstrations showed the P-51's excellent rate through crisp aileron responses. The aircraft snapped from side to side faster than German pilots expected. Direction changes happened instantly. Predictive maneuvering became nearly impossible against such quick responses. Mock dogfights against German fighters illustrated both strengths and weaknesses clearly. The Mustang dominated in specific areas while remaining vulnerable under certain conditions. German pilots learned when their aircraft retained advantages and how to create those situations. Knowledge meant survival in actual combat. Ground examinations followed flying displays with pilots and mechanics crowding around the captured machine. Cockpit layouts revealed American design philosophy. Instrument panels showed different approaches to pilot information. Control placement reflected combat priorities. Everything could be touched and studied closely. Test pilots answered detailed questions based on extensive experience flying the machine. These conversations provided concrete understanding of enemy capabilities. Myths dissolved under direct examination. Reality replaced propaganda. German personnel gained honest appreciation of what they faced. Mock combat sessions provided the most valuable component of base visits. Selected German pilots flew their operational aircraft against captured types under careful observation. Real combat dynamics emerged through controlled engagements. Effective tactics separated from wishful thinking. One demonstration at a Jagdgeschwader 1 base during late 1944 illustrated these lessons perfectly. Allied bomber operations intensified daily. German losses mounted accordingly. The base commander arranged for experienced pilots to fly mock engagements against the captured Mustang. Knowledge would transfer to squadron mates through direct experience. The German test pilot flying the P-51 demonstrated standard American tactics with devastating effect. Speed and climb advantages maintained energy throughout every engagement. Situations that favored German turn performance were studiously avoided. Energy management techniques proved superior to traditional dogfighting approaches. German pilots flying Messerschmitt Bf-109Gs and Focke-Wulf FW-19DOAs attempted standard Luftwaffe tactics against the Mustang. These approaches had worked against earlier Allied fighters. Against the P-51 they failed completely. The difficulty of successful engagement became immediately obvious. Aggressive pursuit resulted in the Mustang simply accelerating away. Distance opened faster than pursuing German fighters could close it. Superior speed negated every attempt at close engagement. German pilots found themselves chasing vapor trails while burning precious fuel. Attempts to climb above the Mustang for diving attacks failed equally badly. The P-51 outclimbed every German pursuit. Superior altitude belonged to the American aircraft first. Tactical situations reversed before German pilots could exploit their intended advantages. Forcing sustained turning fights where Bf-109 superiority should have dominated proved futile. The Mustang pilot refused engagement by extending away at high speed. Energy advantage renewed itself through superior performance. Return attacks happened when conditions favored the American aircraft. These mock combat sessions sobered German pilots who had maintained hopes about competitive aircraft performance. Direct experience destroyed comfortable illusions about tactical parity. The deteriorating strategic situation reflected genuine capability gaps that skill alone couldn't overcome. Dynamic combat maneuvering revealed the Mustang's fundamental advantages clearly. American pilots flying P-51s possessed significant tactical superiority. High-altitude bomber escort combat played directly to every American strength. German disadvantages multiplied at the altitudes where battles actually occurred. This pattern of gradual realization repeated itself across numerous Luftwaffe bases throughout late 1944 and early 1945. The Wanderzirkus Rosarius conducted demonstrations that followed identical scripts with identical results. Pre-demonstration briefings assured German pilots about continuing aircraft superiority or competitive parity. Actual flight demonstrations contradicted optimistic assessments with undeniable evidence. Captured aircraft showed capabilities that significantly exceeded official propaganda claims. German fighters faced formidable opponents whose advantages couldn't be explained away through clever rhetoric. Walter Dahl commanded fighter units during 1944 and later wrote about Wanderzirkus Rosarius visits in his memoirs. Historians note reliability issues throughout his accounts requiring careful interpretation. His descriptions capture the unusual atmosphere these demonstrations created across German bases. Captured American fighters arrived alongside captured heavy bombers, creating peaceful scenes where enemy aircraft parked next to German machines. Pilots examined foreign designs with professional curiosity. Formation leaders received opportunities to fly captured aircraft in controlled mock combat situations. Personal experience replaced second-hand reports and official briefings. Dahl emphasized the substantial value of this direct training. Familiarity with enemy aircraft characteristics represented factors that couldn't be underestimated in aerial combat. Split-second decisions often determined survival outcomes. Flight leaders conducted detailed training lectures following demonstration sessions. Squadron members received specific recommendations and tactical insights based on direct observations. Personal experience flying captured Allied aircraft provided credible foundation for these presentations. Systematic knowledge transfer helped prepare German pilots for combat encounters with realistic expectations. Allied strengths became known quantities rather than mysterious threats. The increasingly limited circumstances under which German fighters retained exploitable advantages were clearly identified and emphasized. The program achieved decidedly mixed results as Germany's strategic situation deteriorated across all fronts by late 1944. Demonstrations unquestionably provided valuable tactical intelligence. German pilot understanding of Allied aircraft capabilities improved significantly through direct exposure and hands-on experience. This knowledge couldn't overcome fundamental and growing disadvantages German forces faced on every level. The Luftwaffe suffered chronic and worsening fuel shortages that severely limited flight training hours for replacement pilots. Inadequately prepared pilots reached combat units with minimal experience. Experienced pilots who understood through hard-won combat knowledge how to fight effectively against aircraft like the P-51 became increasingly rare. Relentless attrition during brutal air combat throughout 1944 consumed veteran pilots faster than replacements could be trained. German fighter pilot losses reached completely unsustainable levels. Aircraft production remained surprisingly high, despite intensive Allied strategic bombing of German industry. Manufacturing output couldn't replace losses quickly enough to maintain operational force strength. Quality control suffered under dispersed production necessitated by bombing threats. Training revelations from captured aircraft often served primarily to demoralize rather than inspire German personnel. Pilots realized the full extent of their disadvantages through direct comparison. Hope dissolved under harsh mathematical reality of performance specifications. German pilots recognized with growing clarity that they flew inferior aircraft in the most critical performance categories for assigned missions. The P-51 speed advantage couldn't be matched by any German fighter in operational service. Extraordinary range exceeded German capabilities by enormous margins. Superior high-altitude performance dominated the combat environment where battles occurred. Technical intelligence gathered from captured Mustangs extended well beyond simple flight testing and combat evaluation procedures. German engineers at Rechlin and Göttingen systematically disassembled P-51 components to understand American manufacturing techniques and design approaches. Wing structure and airfoil sections received meticulous, detailed examination. Construction methods were studied and documented. Engineers attempted to understand precisely how American designers achieved such aerodynamically efficient performance through specific structural approaches. The Packard Merlin 1653 engine generated intense interest among German technical specialists. The sophisticated two-stage supercharger system with intercooler enabled impressive high-altitude performance that no German engine could match. Internal components revealed advanced metallurgy and precision manufacturing. Fuel system design received careful attention as engineers attempted to decode the secrets of remarkable range achievement. Tank placement and fuel flow management systems showed sophisticated approaches to weight distribution and center of gravity control throughout flight profiles. Hydraulic systems were evaluated for reliability and maintenance accessibility compared to German equivalents. Consistent high quality of materials used throughout the aircraft impressed German investigators. American access to strategic materials created significant advantages. High-grade aluminum alloys exceeded German material quality significantly. Specialized steels provided strength characteristics unavailable to German manufacturers. Reliable rubber compounds enabled consistent seal performance that German substitutes couldn't match. Superior materials allowed designers to create structures that effectively combined strength with acceptable weight while maintaining production efficiency. Germany faced increasingly severe material shortages by 1944 that forced inferior substitute materials into critical applications. Manufacturing technique investigations revealed sophisticated approaches that enabled true mass production without compromising quality standards. American factories produced P-51s using highly developed assembly line methods. Remarkably tight tolerances remained consistent across thousands of individual aircraft. German production had become increasingly reliant on dispersed manufacturing in smaller facilities scattered across the country. Allied bombing forced this dispersion to avoid concentrated targeting. Inadequately trained forced labor created quality control problems and reduced production efficiency. Inconsistent quality plagued late-war German aircraft. Maintenance problems increased accordingly. Operational availability suffered as aircraft spent more time undergoing repairs. Combat effectiveness declined as fewer aircraft remained mission-ready on any given day. The captured Mustang, designated T9 plus HK, served with the Wanderzirkus Rosarius until December 10, 1944, when the aircraft and pilot, Oberleutnant Leopold Schanz, were lost. Historical records don't definitively specify whether the aircraft crashed during demonstration flights. Ground destruction during Allied air raids against stationed airfields remains another possibility. Other wartime circumstances might have claimed both aircraft and pilot. By that point, the machine had traveled extensively across Germany, visiting numerous Luftwaffe bases. Direct hands-on education reached hundreds of German pilots who gained invaluable first-hand knowledge of American aircraft capabilities. This knowledge transferred throughout the fighter force as trained pilots shared insights with squadron mates and operational units. Other captured Mustangs served similar evaluation and demonstration roles for the Luftwaffe throughout the remaining war period. German records and post-war research indicate at least two P-51s definitely operated with the Wanderzirkus Rosarius at various times during 1944 and early 1945. Aircraft bearing Luftwaffe codes T9 plus, CK, and T9 plus HK provided demonstration services across multiple bases and training facilities. Historical sources sometimes incorrectly list additional P-51s that careful research reveals were actually different aircraft types. T9 plus FK was actually a captured P-47D Thunderbolt rather than a Mustang. T9 plus PK was a captured Soviet Lavochkin LA-5FN fighter. Accurate identification requires careful verification of primary source documents and photographic evidence. The T9 designation code wasn't officially assigned to any existing Luftwaffe operational formation according to German organizational records. This strongly suggests the code represented an ad hoc system used specifically for Wanderzirkus Rosarius captured aircraft operations rather than following standard organizational structure. Documentation indicates one captured P-51B operated at Neuruppin Airfield, located approximately 60 kilometers northwest of Berlin. This aircraft trained Hungarian fighter pilots on effective tactics for using their Focke-Wulf FW-190s against American Mustangs in combat. Knowledge transfer to German allies reflected recognition that the Mustang represented a significant and growing threat requiring specialized counter-tactics. This information needed wide dissemination throughout Axis air forces facing similar challenges. Training emphasized identifying and exploiting limited areas where German and Hungarian fighters retained advantages. Sustained turn performance at lower speeds and altitudes provided some opportunities. Situations that played directly to Mustang overwhelming strengths were studiously avoided. Speed superiority, climb rate advantages, and high-altitude performance dominance represented areas where German aircraft couldn't compete effectively. Tactical doctrine developed around these harsh realities rather than wishful thinking about competitive parity. Broader implications of German pilots directly experiencing and thoroughly understanding superior American fighters extended well beyond immediate tactical considerations. The Mustang represented tangible, undeniable evidence of American industrial and engineering capabilities. Years of propaganda about American industrial and technical inferiority crumbled under direct comparison with captured hardware. Uncomfortable realizations challenged fundamental assumptions about relative national capabilities and industrial strength. Declining morale among German pilots reflected growing understanding that they fought at severe and growing disadvantages. No amount of individual skill, personal courage, or tactical cleverness could fully overcome systematic performance gaps between aircraft types. The Mustang's range capabilities particularly troubled German commanders who clearly recognized decisive strategic implications. The bomber war over Germany had seemed potentially containable when Allied escorts possessed limited range, requiring fuel stops or early return to base. Continuous escort coverage throughout entire missions became possible once Mustangs entered operational service. German fighters could no longer wait for escorts to reach fuel limits before attacking bomber formations. Every bombing mission featured fighter escort from beginning to end. Risk levels increased dramatically for German pilots attempting intercepts of bomber formations. Fighting through screens of superior Allied fighters became necessary just to reach bomber targets. Attrition rates climbed accordingly as combat became more dangerous. Production numbers told devastating stories about relative industrial capacity between combatant nations. American factories produced approximately 500 P-51s monthly by late 1944. This figure would climb even higher, reaching 881 aircraft monthly by January 1945 at peak production. This output exceeded more than double the combined production rate of all German single-engine fighter types, including Bf-109s, Fw-190s, and newer developmental aircraft. Quantity advantages compounded quality superiorities to create overwhelming material superiority. Mustangs were equipped with reliable engines built to consistent quality standards throughout production runs. Sophisticated and accurate instruments provided pilots with dependable flight information. Radio equipment actually worked consistently and reliably, unlike often unreliable German equivalents. American pilots flew properly maintained aircraft, serviced by well-trained ground crews with adequate supplies. Genuine spare parts remained available rather than inferior substitutes. Proper tools and technical manuals supported maintenance operations effectively. German forces struggled with increasingly severe maintenance challenges created by parts shortages and substitute materials. Undertrained personnel, including forced labor workers, lacked skills for proper maintenance procedures. Dispersed maintenance facilities operated under suboptimal conditions. American pilot training quality and thoroughness became increasingly apparent through combat encounter analysis by surviving German pilots. American pilots typically arrived at operational units with 200 to 400 hours total flight training time, including extensive advanced instruction. Combat tactics training, instrument flying under various weather conditions, and formation procedures prepared American pilots thoroughly for operational realities. German pilot training had been dramatically and dangerously shortened by late 1944 due to severe fuel shortages. Training facilities and experienced instructors were lost to Allied bombing and combat attrition. New pilots sometimes arrived at frontline units with barely 100 hours total flight time. Minimal combat training left them unprepared for operational realities. Instrument training was often completely absent, leaving pilots dangerous, unprepared for weather flying. These inadequately trained pilots faced veteran American pilots flying objectively superior aircraft. Predictable results reflected in German loss statistics throughout this period. German loss rates among fighter pilots increased dramatically and unsustainably during 1944 and early 1945. Experienced pilots who understood through hard-won combat experience how to maximize aircraft strengths while minimizing exposure to enemy advantages were killed faster than replacements could be trained. New pilots with minimal training survived only a handful of missions on average before being shot down. Bailing out successfully represented good fortune. Death represented the more common outcome for inexperienced pilots facing overwhelming odds. The Luftwaffe hemorrhaged its most valuable and irreplaceable asset. Skilled, experienced pilots with knowledge and judgment necessary for survival and effectiveness died at rates that couldn't possibly be sustained by any training program. Wanderzirkus Rosarius demonstrations revealed these harsh realities directly to German pilots before they encountered them in actual combat where stakes involved life and death. Advanced preparation theoretically improved survival chances by providing realistic understanding of combat conditions. Simultaneously, the demonstrations made painfully clear the deteriorating situation German forces faced across all dimensions of the air war. Pilots who flew captured Mustangs or observed demonstration flights understood with uncomfortable clarity the opponents they would face. Significant and fundamental performance advantages belonged to American aircraft in areas that mattered most. Speed, range, high-altitude capability, and overwhelming numerical superiority created conditions where German success required perfect execution while American pilots enjoyed substantial margins for error. The brutal reality struck deep into every German pilot's mind during those final desperate months. Each man knew what he faced when American formations appeared on the horizon. Those sleek silver Mustangs could outrun anything Germany had in the sky. The psychological weight crushed morale more than any bomb. Some German test pilots spent countless hours flying captured P-51s through rigorous evaluation flights. Mock battles filled their days. These enemy aircraft impressed even hardened veterans. Professional respect grew despite the bitter circumstances. They witnessed engineering brilliance that couldn't be ignored. American designers had created something remarkable. The Mustang revealed its true nature through extended testing. Every system worked in perfect harmony. Speed mattered more than tight turning circles. Range exceeded anything German fighters could achieve. High-altitude performance dominated the stratosphere. These characteristics served the strategic mission flawlessly. Bomber escort demanded these exact capabilities. American engineers made smart choices. They understood mission requirements completely. Pure dogfighting ability took second place to practical needs. Long-range escort duty drove every design decision. Deep penetration into Germany required specific performance parameters. The Mustang delivered exactly what Bomber Command needed. Manufacturing excellence amazed German observers who understood production challenges intimately. Their own aircraft designs often ignored factory limitations. Complex construction methods slowed production rates dramatically. The Mustang embraced mass production from day one. Modular construction allowed parallel manufacturing streams. Standardized components reduced training time significantly. Assembly operations stayed deliberately simple throughout. American factories maintained consistent quality despite enormous production volumes. The basic design accommodated manufacturing requirements perfectly. German approaches typically prioritized absolute performance over production reality. Their aircraft remained difficult to build even under perfect conditions. War-torn Germany faced anything but perfect conditions by late 1944. The Packard-built Merlin engine, powering Fraser's captured P-51B, represented another area of American superiority. Packard successfully manufactured these complex Rolls-Royce designs under license agreements. Thousands rolled off production lines with remarkable consistency. The two-stage supercharger system with intercooler enabled extraordinary high-altitude capability. German inline engines simply couldn't match this performance level. Reliability impressed ground crews who maintained these captured aircraft daily. Field conditions tested every component severely. The Merlin proved remarkably maintainable under harsh circumstances. German inline engines like the Daimler-Benz DB605 suffered increasing quality problems throughout 1944. Material shortages forced inferior substitute materials into production. Dispersed manufacturing to avoid bombing raids destroyed quality control effectiveness. The psychological damage to German pilots ran deeper than simple morale problems. These men had started the war with supreme confidence. Superior training formed their foundation. Advanced aircraft gave them technological advantages. Proven tactical doctrines guided their actions. Victory seemed assured in those early days. Extended combat experience systematically destroyed that confidence by late 1944. Direct exposure to captured Allied aircraft through testing programs provided undeniable proof. The performance gap couldn't be wished away or explained by propaganda. German pilots recognized painful truths about their situation. Allied advantages appeared decisive in every critical category. Aircraft performance favored the enemy completely. Overwhelming numbers made resistance nearly futile. Logistics support reached every Allied unit effectively. Training programs prepared Allied pilots thoroughly. Intelligence gathering provided accurate tactical information. Fighting under such conditions required extraordinary courage bordering on fatalism. Death or severe injury became likely outcomes for every mission. Former Luftwaffe accounts from this desperate period describe hopeless feelings that haunted every pilot. American fighter formations appeared on distant horizons like harbingers of doom. Tactical maneuvers couldn't avoid these encounters. No German fighter in operational service could outrun Mustang formations. Physics and engineering had settled the matter decisively. High-altitude engagements meant fighting at severe disadvantages across every performance category. Declining to engage allowed American bombers to strike targets without opposition. Germany's military and industrial collapse accelerated with each unopposed raid. Neither choice offered acceptable outcomes from any professional military perspective. These stark options faced German fighter pilots daily during the war's final year. Strategic situations had deteriorated beyond any possibility of meaningful reversal. The Wanderzirkus Rosarius continued operations into early 1945, despite mounting difficulties. Demonstrations with various captured aircraft required sufficient aviation fuel supplies. Operational airfields needed constant maintenance against advancing Allied forces from multiple directions. Eastern and Western fronts collapsed simultaneously as Allied armies advanced deeper into German territory. The specialized unit's ability to travel safely between operational bases diminished steadily. Eventually, operations ceased entirely as Germany's military organization collapsed completely. Even high-priority units like test and evaluation groups lost access to scarce resources needed for continued operations. Various captured P-51s operated by German forces met different fates as the war ended. Incomplete records and administrative chaos make precise accounting impossible. Some aircraft certainly perished during Allied air raids against German airfields. These attacks intensified dramatically during 1945 as Allied air superiority became absolute. Retreating German forces deliberately destroyed other captured aircraft to prevent recapture by rapidly advancing Allied armies. Standard military procedure demanded denying useful equipment to advancing enemies. A few examples possibly survived until war's end, and subsequent recovery by Allied forces entering Germany. Detailed records of such specific recoveries remain limited or completely lost. Knowledge gained from systematic Mustang testing provided German pilots with valuable tactical intelligence about aircraft capabilities. Optimal engagement parameters became clearer through direct experience. Exploitable weaknesses revealed themselves during extensive flight testing. But this hard-won knowledge ultimately couldn't overcome fundamental disadvantages facing the Luftwaffe by 1944. Understanding intellectually that Mustangs could outrun, outclimb, and dramatically outrange German fighters offered limited practical benefit. German pilots still faced direct orders to engage these superior aircraft in defense of German territory. Professional military duty demanded compliance regardless of probable outcomes. The sophisticated testing and demonstration program represented systematic attempts to counter Allied advantages through tactical innovation. Improved pilot knowledge might provide marginal benefits in specific situations, but tactics and knowledge alone couldn't compensate for inferior aircraft performance across all critical categories. Severe numerical disadvantages made victory mathematically impossible. Inadequate training due to chronic fuel shortages reduced pilot effectiveness significantly. Spare parts shortages grounded aircraft that might otherwise fly combat missions. Experienced maintenance personnel became increasingly scarce as the war progressed. Lieutenant Thomas Fraser's P-51B 15NA, with serial number 4324825, enjoyed an extraordinary afterlife following his forced landing on D-Day. The crashed fighter lying in a French field became something far more significant. German recovery teams transformed it into an instrument of revelation for Luftwaffe personnel. American engineering capabilities received concrete demonstration through systematic flight testing. Allied air superiority became undeniable fact rather than propaganda claim. No amount of official information could overcome direct personal experience with enemy aircraft capabilities. The aircraft served this crucial educational role until its final loss in December 1944. Extensive travels across Germany provided hands-on experience to hundreds of Luftwaffe personnel. Sobering, realistic assessments replaced optimistic hopes based on incomplete information. Captured Mustangs in German service illustrated the sophisticated, professional approach the Luftwaffe maintained toward understanding enemy capabilities. Germany's deteriorating strategic position didn't prevent systematic intelligence-gathering efforts. Rather than relying solely on fragmentary combat reports of uncertain reliability, German forces invested significant scarce resources in comprehensive testing programs. Recovering crashed Allied aircraft required dangerous operations in contested areas. Repairing battle damage demanded skilled technicians and precious materials. Systematic flight testing consumed valuable aviation fuel and pilot hours. These resources were desperately needed elsewhere as Germany's situation worsened. Controlled testing conditions provided more reliable intelligence than hurried combat encounters. This systematic approach represented best military practices for organizations seeking accurate understanding of opponent capabilities. The effort continued even as Germany's strategic situation became increasingly hopeless. The Wanderzirkus Rosarius program demonstrated that sophisticated intelligence gathering, professional competence, and systematic analysis couldn't overcome fundamental material disadvantages. German pilots gained valuable knowledge about Mustang characteristics and optimal tactics for engaging them. But this hard-won knowledge primarily confirmed what many already suspected through combat experience. Allied aircraft possessed significant decisive performance advantages that German industry couldn't match during the war's final years. Resource constraints and strategic circumstances prevented competitive responses to Allied technological developments. German test pilots confronting Mustang capabilities faced the same brutal realities affecting broader German military experience across all theaters. Initial confidence in German technological superiority gradually eroded through direct contact with Allied forces. Tactical innovation couldn't overcome decisive Allied advantages in multiple critical areas. Industrial capacity favored the Allies overwhelmingly. Access to strategic resources remained uninterrupted for Allied forces. Enormous manpower reserves sustained Allied operations indefinitely. Technological capabilities increasingly matched or exceeded German achievements in key areas. The Mustang represented one particularly visible manifestation of these broader Allied advantages. American designers created aircraft excelling at intended strategic missions. American industry produced them in enormous numbers with consistent quality despite design complexity. American training programs prepared pilots thoroughly to extract maximum performance from advanced aircraft in combat situations. German forces could study, analyze, and appreciate these advantages through programs like the Wanderzirkus Rosarius. But replicating or effectively countering them remained impossible given strategic and material constraints. Technical sophistication of the P-51 challenged and ultimately demolished German assumptions about American engineering capabilities. Propaganda had carefully cultivated these assumptions over many years. Official information portrayed Americans as capable of producing simple, rugged equipment in vast quantities. But fundamental incapability for sophisticated design, requiring engineering excellence, remained official doctrine. The Mustang demonstrated conclusively that American engineers could create highly refined, efficient designs. These designs matched or exceeded German capabilities in strategically important areas. Wing design represented advanced aerodynamic research successfully implemented in high-volume production. Complex mathematical calculations had produced elegant solutions to difficult engineering problems. The Packard-built Merlin engine demonstrated American capability to manufacture sophisticated high-performance engines in large quantities. Quality control remained consistent despite enormous production volumes. Aircraft systems integration reflected sophisticated engineering that successfully balanced multiple competing requirements. The result was a coherent, effective weapons system optimized for its intended strategic mission. German pilots flying captured Mustangs extensively couldn't honestly dismiss American engineering as crude or unsophisticated. Direct personal experience contradicted propaganda claims completely. They experienced aircraft that handled beautifully across complete flight envelopes. Performance remained superb in mission profiles that mattered strategically. Thoughtful, competent design appeared throughout every system and component. This direct experience forced acknowledgement that American technical capabilities exceeded German preconceptions significantly. Implications extended well beyond aircraft design to broader questions about relative national capabilities. Industrial production, technical education, and engineering sophistication all required reassessment based on concrete evidence. The strategic air campaign over Germany succeeded largely because of the P-51 Mustang's unique combination of capabilities. No other aircraft could match this specific set of performance characteristics. Long-range bomber escort deep into Germany remained operationally impossible until Mustangs arrived in substantial quantities during early 1944. Previous Allied escort fighters possessed considerable capabilities in other operational areas. The Republic P-47 Thunderbolt excelled as a ground attack aircraft. The Lockheed P-38 Lightning performed well in Pacific theater operations, but insufficient range prevented accompanying heavy bombers throughout complete missions to targets deep inside Germany and back to English bases. This critical limitation allowed German fighters to wait until escorts reached fuel limits and turned back toward their bases. Bomber formations became vulnerable during the most dangerous portions of their missions. Concentrated attacks during these periods produced unsustainable bomber losses. Deep penetration raids required suspension until adequate escort became available. The Mustang fundamentally transformed bomber escort operations by providing continuous effective fighter coverage throughout entire missions. Target distance no longer determined escort availability. German fighters couldn't find extended periods when bombers flew without protective escorts overhead. Operational reality forced German pilots to engage American fighters directly rather than simply attacking bomber formations. Risk levels for German pilots increased dramatically on every interception mission. Combined with growing Allied numerical superiority and declining German pilot quality due to reduced training time, Mustang escorts made bomber operations over Germany operationally sustainable. German attempts at interception became increasingly costly, ineffective, and ultimately futile. The mathematics of attrition warfare favored the Allies completely. German pilot losses couldn't be replaced at sustainable rates. Aircraft production couldn't match Allied output levels. Strategic materials became increasingly scarce as Allied bombing intensified. The Luftwaffe conducted extensive technical evaluation of captured P-51s at multiple specialized facilities throughout Germany. Göttingen provided particularly detailed performance testing under controlled scientific conditions. German engineers created comprehensive technical reports documenting Mustang capabilities in systematic detail that military planners could use. Speed measurements at various altitudes revealed performance characteristics across the operational envelope. Climb rate testing throughout the altitude range showed vertical maneuvering capabilities. Absolute ceiling tests determined maximum operational altitude under standard atmospheric conditions. Range evaluations under various fuel and armament configurations provided crucial tactical intelligence. Handling characteristics received thorough analysis across the complete performance envelope under controlled test conditions. German engineers documented all findings in detailed technical reports for distribution within aviation circles. Direct comparisons with German fighter types under equivalent conditions revealed relative performance differences accurately. Specific design features contributing to observed performance received careful analysis and documentation. These technical reports circulated widely within German aviation communities. Aircraft designers learned about Allied technical approaches through systematic study. Tactical planners received accurate performance data for operational planning purposes. Operational commanders gained realistic assessments of Allied capabilities for tactical decision-making. Technical reports confirmed what combat pilots had been reporting from actual combat engagements over many months. The Mustang possessed significant decisive performance advantages in the most critical categories for strategic bomber escort missions. Systematic analysis highlighted specific capability areas where German aircraft couldn't compete effectively. Exceptional range enabled strategic escort missions deep into German territory. Superior high-altitude performance came from the sophisticated two-stage supercharged engine installation. High maximum speed provided tactical flexibility during combat maneuvering. Harmonious handling characteristics reduced pilot workload and enabled effective combat operations. German engineers noted and carefully documented specific design features contributing to these remarkable capabilities. Aerodynamically efficient wing design reduced drag while maintaining structural strength. Powerful, sophisticated supercharged engine installation provided consistent high-altitude performance. Large internal fuel capacity supplemented by external drop tanks enabled extraordinary range. Thoughtful systems integration throughout the aircraft optimized overall performance. Technical intelligence gathered through systematic testing supported conclusions that existing German fighter designs required substantial improvements to remain competitive. Current Allied aircraft types represented significant advances over earlier designs. Future Allied developments would certainly incorporate lessons learned from ongoing operations. Germany initiated several ambitious fighter development programs during 1944, specifically intended to counter Allied air superiority through advanced technology. The Focke-Wulf FW-190D featured inline engines for improved high-altitude performance over earlier radial engine variants. The Focke-Wulf Te-152 specialized in high-altitude interception missions against Allied bombers. Revolutionary jet and rocket-powered designs promised to leapfrog Allied piston engine performance through advanced propulsion technology. These programs reflected clear recognition among German designers and military leaders. Existing German fighters like the Bf-109G and FW-190A couldn't effectively counter advanced Allied aircraft given performance gaps in critical operational areas. Severe material shortages prevented these advanced designs from reaching full production potential. Allied bombing caused production delays that affected development schedules significantly. Resource constraints limited prototype construction and flight testing programs. The rapidly deteriorating overall war situation prevented advanced designs from entering operational service in numbers sufficient to influence strategic outcomes. The jet-powered Messerschmitt Me-262 represented Germany's most successful attempt to achieve revolutionary performance advantages through turbojet technology. Substantial speed and firepower advantages made it extremely deadly against Allied bombers when flown by skilled, experienced pilots who understood how to exploit its unique capabilities effectively. Chronic engine reliability problems limited operational availability significantly below theoretical performance levels. Extensive concrete runways required for safe operations remained vulnerable to Allied attack. Vast quantities of increasingly scarce aviation fuel consumption made sustained operations difficult. The type arrived too late in far too small numbers to alter strategic outcomes or seriously threaten Allied air supremacy. Even the Me-262's impressive technological advantages proved strategically insufficient to overcome overwhelming Allied numerical superiority. The Luftwaffe's collapsing infrastructure couldn't support advanced aircraft operations. Fuel supplies dwindled to critically low levels. Pilot training programs produced inadequately prepared pilots due to time constraints. World War II's final year in Europe witnessed the Luftwaffe's systematic dissolution as an effective fighting force capable of meaningful resistance against Allied operations. Catastrophic pilot losses couldn't be replaced at sustainable rates. Severe and worsening fuel shortages grounded aircraft that might otherwise fly combat missions. Production difficulties caused by intensive Allied bombing disrupted manufacturing schedules continuously. Overwhelming Allied numerical superiority made effective resistance mathematically impossible. These factors combined to render German air defense increasingly ineffective, regardless of individual pilot skill, courage, or determination. The captured aircraft testing program continued operating as long as practically possible under deteriorating conditions. Attempts to provide tactical intelligence that might improve German pilot survivability continued, even as strategic outcomes became inevitable. Final defeat approached with mathematical certainty that no amount of tactical knowledge could prevent. German pilots who flew captured Mustangs extensively and understood Allied aircraft capabilities through direct personal experience faced the war's end with complex, mixed emotions. Professional pilots could appreciate engineering achievements represented by aircraft like the P-51, even while regretting their service on history's losing side. Many harbored no illusions about Germany's defeat being anything other than total and unconditional surrender. They had witnessed firsthand the overwhelming material advantages Allied forces possessed in every dimension of modern military power. Industrial capacity, technological sophistication, resource availability, and trained personnel all favored the Allies decisively. The captured Mustang testing program represents a fascinating, instructive chapter in World War II aviation history. It illustrates how professional military organizations attempt to understand and counter opponent advantages through systematic intelligence gathering even under desperate circumstances. The program provided tactically valuable knowledge to German pilots through direct experience with captured enemy aircraft. But this knowledge ultimately couldn't overcome fundamental imbalances in industrial capacity, resource availability, technological capabilities, and trained personnel. These imbalances characterized the air war during 1944 and 1945 completely. German forces fought with remarkable courage, impressive tactical skill, and professional competence throughout. But they faced opponents with superior resources, better equipment, more thorough training, and advantageous strategic positions that proved absolutely decisive. Professional acknowledgement by German test pilots that they had never encountered handling characteristics like those demonstrated by the Mustang represented realistic recognition. American engineering achievement couldn't be dismissed through propaganda or ideological assumptions. Significant performance gaps German pilots faced in combat operations were undeniable facts. This acknowledgement came through direct personal experience rather than second-hand intelligence reports. Confronting uncomfortable realities sometimes requires direct experience that cannot be dismissed or explained away through wishful thinking. Professional military personnel must deal with factual information regardless of its implications for morale or strategic planning. The legacy of the Wanderzirkus Rosarius and similar intelligence programs extends beyond immediate tactical impact. It demonstrates the value of systematic intelligence gathering under any circumstances. Professional competence in technical evaluation remains essential for military organizations. Honest assessment of enemy capabilities must continue even under the most difficult strategic circumstances imaginable.